let me welcome Kyle Kotowick, founder and CEO of Invicton Labs. Dr. Kyle Kotowick is a founder of a Canadian consulting development firm focusing on cloud infrastructure, security, and Internet of Things implementation of high-growth clients. He has completed his PhD in MIT Computer Science and Artificial Intelligence Laboratory, joined with the Department of Aeronautics and Astronautics. He has also served as a consultant, systems architect. I'm not forgetting anything. This is a very big list, so let me get this right. And developer for global firms, startups, and university. So as a lead engineer for the Government of Canada and as a researcher for the military navigation systems for life support systems in space. Kyle, welcome. Let's hear everything about no password, building a passwordless cloud infrastructure. Welcome.
The stage is yours.
That was definitely the most thorough intro I've ever experienced, which is kind of great. Can we get the presentation up? Thank you. So, as that intro covered pretty in detail, we're here to talk to you today about how we can develop our internal infrastructures, our platform infrastructure, without using any passwords, and why that's a good idea. So as mentioned, I did my PhD at the Massachusetts Institute of Technology, where I focused on aeronautics and astronautics, aircraft and spacecraft, and particularly on human systems integration. So how we develop these very complex technologies that humans operate and how they integrate with those things. Why does that matter for passwords or infrastructure? Well, it turns out that most of the issues we have with passwords are due to the humans who are involved with them. Humans forget their passwords. They write down their passwords on sticky notes and stick them to their monitors. They come up with 123 my birthday as their password. Humans are the problem with conventional password technologies. And to explain what that actually means, let's quickly review what I mean by a password and how it fits into the context of this talk. By password, I mean a string value that is used to authenticate or authorize with any kind of automated system. And it's usually provided as is in a plain text format, something that doesn't require any further processing in order to actually be a credential. So if I hold it, I have access. And that includes a lot of different things. Obviously, conventional passwords, but also API keys, one-time tokens with a long lifespan, SMS or email MFA tokens, or magic links. If you use Slack, you've seen those. Basically anything, like I said, if you hold it, it gives you access to something. And these passwords can leak in many different ways and get out into the world where we don't want them to be. And we'll go over a couple of those to really understand how critical this issue actually is. First, we have passwords that are shared in plain text. And in my line of work, I've worked with dozens of different clients, large enterprises down to new startups, and almost every one of them does something like this at some point. They will put it in plain text, they'll put it in chat, and that is now exposed to the world forever. Don't put your passwords in chat. It's a bad idea. But what if we have a shared password and we don't want to do that? Well, maybe we can use a password manager. Not a bad idea. And then we can share access to that. But these things aren't immune either. In 2022, LastPass had its development environment breached, and attackers were able to get into that dev environment. Okay, not critical, it's just development, but if you can get into dev, you can start pushing malicious code, you can start getting things in there that might make it through code review into production and cause all sorts of issues. In 2022, there was a CVE from KeepPass because their passwords were written into plain text in the system log, so anyone who could access the system log file could see the passwords. And in 2023, they had another CVE where the master password, which unlocks everything, could be accessed through a memory dump even after the application had been closed. And then there's the human factors element of it as well. Who manages this access? What happens if you have an employee who's been given access to a shared password vault and they move to another department, or they change roles, or their employment is terminated? How do you actually make sure that this is constantly kept up to date and that that employee does not retain access to things they shouldn't have? That's a very common issue. We can also lose passwords through CI/CD systems. There have been quite a few of these in recent years. In 2021, CodeCov had 29,000 clients had their credentials breached, including some very big names like HashiCorp, Mozilla, and Twilio. Also in 2021, Travis CI had an issue where attackers were able to access secrets by forking public repositories and then printing out some of the workflow values. So CI/CD systems are a pretty big contributor to this as well. What about passwords that are locally stored and never rotated? If anyone's ever worked with AWS, you might recognize this file on the left. This is an AWS credentials file, which gets stored locally on your computer. And on the right, check. Okay. Technology is difficult. So on the right, we have an RSA private key, which, of course, again, stored locally, can be encrypted with a password, but realistically, how many people actually do that? Not many, and it's hard to enforce that policy among your developers because it's on their local machine and you can't really prove that they've done that. So these things are stored locally, and because of that, anyone who can get access to your machine can just copy these files and now have access to anything. This file on the left, for example, in my line of work, I could have 20 different management accounts for 20 different enterprise clients in there, all with full administrative access, right? That is an incredibly large security risk. Simple passwords and brute force, another common one. In 2022, the #1 breached password was still password, and as much as we talk about this, it's never going to change. People will keep doing that. But of course, as developers, when we're talking about our own internal infrastructure, we would never do something that stupid. That would be ridiculous, right? It doesn't happen. No, it actually happens quite often, and it leads to a number of major issues. And what's interesting about this is that when we talk about password breaches, we often think of a user losing their own password or having it somehow obtained, right? My grandmother having her banking password is her birthday 123, and then someone gets that and steals all her money. I feel bad for my grandmother, but that's just one user. What happens when it's an infrastructure password, when that is a database password that now has 10, 20, 100 million different records in it? And that's when we get into the world of mega breaches, where more than 1 million records have been lost or accessed by an attacker. And these things start getting incredibly expensive, on the order of $10 per record, up into the hundreds of millions of dollars. And this is why it is worth investing some time and money and developer resources into finding better alternatives. And we can see some great examples of this in recent history. 2021, T-Mobile, $500 million settlement for a large data breach. What happened here is some attackers were able to access the internal network through a misconfigured network gateway, and that gave them access to the test environment, and from there they were able to brute force their way into the production environment because the production credentials were very weak. 2019, Equifax, $425 million. Here, there was a vulnerability in Apache struts that they were using, and the attackers were able to achieve remote access into the internal servers. From there, they were able to find and use the production database credentials and extract a lot of information from the database. Now, that's what we expect happen in these cases. These companies are pretty closed about what actually happened for good reason, but that's what we expect was the issue. So when we talk about the risk of password breaches and what can happen with them, the risk is really a factor of two different things: the probability that this issue will happen and the impact if it does happen. So to reduce risk, we can reduce each of these factors. We reduce the probability by using passwords in fewer places. Fewer passwords means fewer things that can be stolen. We store passwords in fewer places. We don't put them in plain text files that are shared on each developer's computer because that reduces the risk of them being breached by an attacker. And we use short-lived passwords so that if a password is breached, there's a reduced chance, a reduced probability that it's active at that time that can actually be used for anything harmful. And then we also reduce the impact. We use the principle of least privilege, or the minimum permissions model, which is possibly the most important thing on this slide, meaning that we make sure that our users are only given the permissions that they absolutely need in order to do their jobs, so that if those credentials are breached, they don't have full administrative access to everything. We monitor and detect for those breaches so that when they occur, we can more easily detect and respond to them to reduce the time that that impact occurs. And we use short-lived passwords, which means that if a password is stolen, it doesn't last very long before it's no longer valid. So in summary, passwords are risky. We want to minimize their use, and we want to minimize their scope when we do have to use them. But overall, passwords are bad, and we would just like to get rid of them altogether if we can. So talking about alternatives in terms of authentication factors, we really have a number of different options, 5 specifically. We have a knowledge-based authentication factor. That's knowing your password. a possession-based factor, which is an MFA device or a certificate installed on a device, something you have. Something that is inherent to the user, and that's where biometrics come in. Your fingerprint or your facial structure or your cornea or iris, these things are inherent to you as a person. Your location, often your IP address in this case, and your behavior or different patterns in your behavior. If Sally is working 9 to 5 most days and all of a sudden there's a login attempt at midnight, that does not fit her behavior pattern, and maybe we need to require additional authentication or block the attempt. Now, when our developers want to work on a beach here in Greece instead of my office in Ottawa, the location factor doesn't work so well, so we get rid of that as an option. It also doesn't fit within the zero trust framework that most companies are trying to develop now under the US NIST standards. So what we use is a combination of knowledge, something you know, and possession, something you have, which is your password and your MFA device. But we want to get rid of passwords. So what we do is we switch to using an inherent characteristic through biometrics, which is used to unlock the device that you possess, which has the key that does the authentication. So we still have 2 factors here, but you don't need to remember anything, and you only need 1 device. And we're starting to see this show up in a number of different technologies. Windows Hello, Mac Face and Touch ID, the FIDO Alliance with its standards including WebAuthn, security keys like YubiKeys. These things are really becoming more popular, fortunately, and provide an alternative to conventional passwords. And we'll look a little bit more in depth at FIDO specifically because it is the current standard that we should all be looking at. So FIDO has an interesting history. It stands for the Fast Identity Online Alliance, and it's a group of different companies and organizations and nonprofits that all have a stake in this matter. And they help try to come up with standards that will work for these types of solutions. So they started with FIDO U2F, which was originally an MFA-only solution. It was a physical device like a YubiKey or security key, and that was the only kind of device that could be used. And it was only usable for second-factor authentication. It couldn't be your primary authentication. So its objective was to replace those one-time passwords that were sent out by SMS or by email as a more secure alternative. It got a bit of adoption, but didn't really pick up too much, simply because a security key is more of a pain for a user to use than just getting a text message or an email code, so it didn't really get that much adoption. But then we had biometrics, and this was in FIDO UAF and FIDO2, the current standard WebAuthn. And here, you start getting that biometric authentication that allows you to not have extra devices. And not only that, but it can be your primary authentication mechanism. So it's not just 2FA anymore, it's actually your main login. So it replaces passwords altogether. And FIDO UAF never really got off the ground. It came out around the same time as U2F, but didn't really get adopted because there were all sorts of conflicting opinions between the main players on how it worked. But FIDO2, WebAuthn, is being adopted very quickly, and so that is the standard we look at and consider for these services nowadays. And we're starting to see these things be adopted by end users or for end users. So we start to see them in mobile apps. Here we have a GitHub login on the left that's asking for my security key. And check, check, check. Oh, they fixed the mic. Okay, cool. I don't have to hold that anymore. Put that down. And it's asking for FIDO2 second-factor authentication here. Mobile apps asking for passkeys. Passkeys came out about in the last year or so. They started becoming popular and supported by the major players. Passkeys are just a fancy term for a FIDO2 key that the general public is more willing to accept as a term they'll actually use. And so we start to see this being offered for end users, right? But we're still not really seeing it being adopted for ourselves, for internal development and infrastructure. And so what we'll focus on is how we can use these concepts for our own systems internally. So what we'll do is we'll go through a general stack of some of the most common components that you'll find in any kind of cloud infrastructure, and we'll look at the conventional mechanism that is used for authentication and then show a passwordless alternative that has the same features but is much more secure and easy to use. So we'll start with an identity manager. This is something like Azure Active Directory or whatever they changed the name to recently, and Google Workspace. These are 2 of the more common ones. And these usually include a number of features like an email service, user and group management, calendars, etc. And conventionally, we log in with an email and a password. Hopefully, these things require a second factor of authentication. Of course they do. We're skilled, secure developers. Why would we not require second factor authentication for these systems? No. Not enough. Only 22% of enterprise clients, of big enterprises with a lot to lose if there's a breach, used MFA for their systems in 2022. So we can do this in a passwordless way that addresses these issues. We're going to use Azure Active Directory simply because it's one of the most common and supports passwordless authentication. And it supports both passwordless authentication using fingerprints, FIDO devices, face recognition. It integrates with Windows Hello if you have that set up in your domain. And it includes all the features we need, like email and calendar and such. So it meets our requirements. So we can set up our users and our user groups, and they can all log in using biometrics and without using any passwords. And this is what is going to be our identity provider. And so we're going to refer to it as an IDP, or a federated identity provider, if you're familiar with SSO principles. For our infrastructure credentials, we'll look at an AWS account, because that's what I work with a lot, but the big players all support this as well. And here we often have very long-lived credentials. In this image here, you can see we have a number of different users, and each of those users is going to have an access key, which will show up in that file that I showed you earlier on, which you store on a local device. Very insecure. These roles often have very expansive permissions, meaning they're a high threat, because we don't like to deal with the minimum permissions model if we don't have to, so we have a tendency to just give ** admin access to all of our users who have access to the admin accounts. And they're stored locally, as I mentioned, so high risk. But we can do this in a passwordless approach as well. We can use something like AWS Identity Center, which used to be called AWS SSO, and we can set up our Active Directory identity provider as a federated IDP, which means that now, when you log into AWS, it redirects you to Azure, where you log in with your passwordless authentication, sends you back, and then based on your user groups that you have in Azure, so if I'm a member of the backend developers group or the infrastructure admins group or whatever you want to call them, based on those different groups that I have, it will grant me different roles that I can access, and so we can control permissions based on group management. So we now have passwordless users who can log in passwordlessly to AWS and have all of their permissions managed by group management. And that is something that you'll hear me come back to repeatedly on every slide, group management. It is absolutely critical when we're working with these kinds of integrated systems, so that when a user changes, if we had user-linked permissions, we would have to change them in a dozen different places. When we do group-based permissions, we only have to remove them from a group in our identity provider, and everything else propagates through after that. How about a VPN? Conventional VPNs using a username, password, or maybe a certificate to log in. Either way, that's a long-lived secret that doesn't get rotated very often. And most organizations do not handle certificate revocation properly. Perhaps some of the larger enterprises do, because they're willing to spend the time and money to set up that kind of infrastructure. But a lot of the small and medium-sized businesses, most startups, will not set up any kind of revocation system like this, which means that once that certificate is out in the world, there's really no way of getting it back. But again, we can do it passwordlessly. AWS, for example, offers a VPN client that is based on OpenVPN, but has integration with the Identity Center that we talked about. So now we can log into our VPN, it'll redirect us to a web browser, we'll log in through Azure Active Directory, redirect us again, and now we're connected to the VPN. No password required. And what's neat about this is not only that, but you can link your authorization rules to the user groups. So you can say, again, backend developers group is allowed to access the production subnets in these different regions. And you can set up those kinds of routing controls based on user group management. So not only are we making it passwordless, but we're also adding additional capability here that might not be present if you're just using certificates or usernames and passwords, depending on how you have it set up. Databases are another very common one. Database users are usually very long-lived in terms of those secrets because they're a pain to rotate. They can be rotated, but realistically, from what I've seen with my clients, most cases they are not rotated on a regular basis, the passwords for those users. And not only that, but a single user in the database is often shared among many different backend services because it's just easier to have one user who can do everything and use that user for everything than to create different users with specific permissions on tables and columns and such, and have that managed between different services. So a pretty big security risk here if anyone can get those credentials, and we saw that in the T-Mobile breach that we talked about earlier. Passwordless, we can do using services like Amazon's relational database service, which supports all the large database options. And it supports something called IAM authentication, which means that we can tie our database user authentication with AWS's built-in authentication system. And as we mentioned earlier, we can have policies connected to those IAM rules, which says that if you have this IAM role, you're allowed to log in as these different database users. And those policies are linked to Identity Center, the AWS SSO system. So now we can log in with Azure into AWS, get a role that allows us to access specific database users based on our groups, and no passwords are required. So we have fully passwordless users for our databases using our federated identity provider. How about Git, our version control and our CI/CD systems? Well, Git itself, especially if we're looking at GitHub, is a pretty big security risk. These are long-lived permissions, again, just a username and password that maybe gets rotated once a year or once every few years. And it's often outside of the organization's control, particularly with GitHub. In most cases, users will create their own personal accounts, and then they'll get invited into an organization. And it's not unless you're paying for the enterprise plans that you get to create your own users and give them their own accounts through your organization. And this kind of access is much more sensitive than it's often considered to be, because if you have access to the source code, even if it's just in the development environment, you can push all sorts of things that can extract secrets. Even if you can't access the secrets that are in your CI/CD system, you can push code that will get them and then upload them wherever you want. So it's quite a high-risk ability to be able to log into and access the code for these things. But we can do it passwordlessly as well. We'll use GitHub again, but GitHub Enterprise is an option. We can actually consider GitHub Enterprise just simply because the pricing is not really that absurdly enterprise priced. And it supports SSO through SAML, so you can connect it with Azure Active Directory like everything else. And now your repository access and your CI/CD access can be linked back to those user groups again. So our backend administrators group will be given permission to accept pull requests, for example, or to access certain branches or to run certain deployment workflows. No password is required to do this at any point. Secrets in your CI/CD system are another major risk. And the reason here is because these are, probably more so than anything else, very long-lived and very infrequently rotated. And it's quite easy to leak them through the workflows and pipelines. We saw with all those CI/CD breaches in the first few slides that these things can get out into the world pretty easily and pretty quickly, with many thousands of clients suffering that exact fate. These secrets are also often linked with very extensive privileges because infrastructure deployments require very wide-ranging privileges, and so we often just grant them administrative ** permissions again, because trying to find minimum permissions model for infrastructure deployments, especially when you have to delete and modify things down the road, can be very time-consuming. They're fairly hard to rotate because you have to link them between your infrastructure provider and your third-party Git or CI/CD provider. And they're fairly hard to trace because when there is a breach, if it happened through an automated workflow, trying to find out and backtrace exactly who made that change, when it occurred, what secrets were revealed, can be quite difficult. But this is one of my favorite slides here, so if you take anything away from this talk, pay attention to this one. Passwordless CI/CD systems are amazing. And they really only became possible within the last year or two with these features released by some of the major providers. But we'll look at GitHub Actions. And what it supports is a GitHub-signed JWT, a JSON Web Token, that is accessible through the workflow every time it's run. So it's a temporary token that's assigned and accessible through the workflow when it runs. And that token includes all sorts of metadata like the name of the repository and organization, the branch that was that activated the workflow, any tags, commit hashes, etc. And then in your infrastructure provider, you can set up an OpenID provider, which you can set to trust the GitHub JWK. So you can say that we're going to trust any JWTs issued by GitHub and signed by this key. And you can create roles with trust policies that allow certain workflows to assume those roles. So I could create a role for production infrastructure deployment that has those permissions, and I can say that a GitHub token that matches this repository on this branch with this other metadata is allowed to assume this role and get those permissions. And so now our GitHub-hosted runner, without any kind of secret stored whatsoever, can use that JWT to assume the role, get temporary credentials, and use those to make API calls to AWS and actually do that deployment. And this was so neat that I created a pretty thorough Terraform module for it, if anyone's interested in taking a look. There are a number of different modules that can do this. This one is specifically for AWS and GitHub, but definitely take a look if you use Terraform at some of those options because they are incredibly easy to set up, and you don't have to do any kind of secrets management in your CI/CD system. So in summary, we've set up an identity and user management system with infrastructure access, VPN access, database user access, code repositories, and a CI/CD system without a single password to be found anywhere in that infrastructure. And this is a list of some of the most common components you'll find, but most of the large cloud providers support passwordless access or some way that you can make it passwordless on almost all of their services. There are still a few that don't support that, but that's quickly changing, and in the short future, everything can be done passwordlessly, I expect. And before I wrap up, I want to touch briefly on selecting vendors. Because as we're talking about these different vendors like GitHub and Azure and AWS, how do you choose which one to use and what should you be looking for? There's a bit of a conflict of interest here because they want to get money from you and you want the most secure features. So there's a couple things to look for. First off, we want to support OIDC or SAML for SSO. Everything I talked about there, all those different pieces of infrastructure require SSO in order to be able to function. You want to look for something that supports role or group-based permissions. Again, a core feature that's required for a secure system. And you want a provider that offers security features at no extra cost to you. Things to avoid are essentially the opposite of those. Any provider that doesn't have any kind of SSO support, user-based permissions, where you link permissions to a specific user instead of to user groups, or services that charge a premium for their security features. And to illustrate this, when I first created this talk just over a year ago, I was using Terraform Cloud and I looked at their pricing page. And there's a couple things to note here. One being that team management, which is that group-based permissions and being able to have different levels of permissions, was a paid feature. At the time, you could only have one type of user, which was an admin, and no other restrictions on permissions. Also, SSO, here under the business or enterprise pricing column. Anyone who's ever worked in this kind of field doing this infrastructure and DevOps work knows that that is a button you do not want to have to click if you can avoid it. And there is a page that I like, that a website called SSO Tax that just does public shaming of all these companies that charge more for SSO, which is kind of funny because SSO is one of the lowest cost things to set up as a software as a service provider because you're outsourcing the work, right? You don't have to do that user management and authentication because you're outsourcing it to the client. So you're actually saving money, and yet it's an enterprise feature that often costs way more. Now, what is kind of neat is that when you public shame companies like this, you can actually drive change. And I don't know if it was this or a bunch of other people complaining about it or me giving this talk a couple times and calling out Terraform and HashiCorp specifically. But when I checked a week ago, it turns out that SSO is now under the free plan. So if you see this and you have a problem with it and you want to use SSO, complain about it, get up on stage and talk about it like I am right now, and you can drive change to make the world more secure. When there is no other option, we always want to use 2FA, of course. It alone will reduce your your password breaches, account breaches by 99-point-some%. Rotate your passwords regularly. A lot of tools that offer password management have built-in rotation, like AWS Secrets Manager, which will rotate your database user passwords for you. Use randomly generated passwords so that brute force attacks, dictionary attacks are much more difficult. And if a password has to be shared, of course, use some sort of password manager or vault with shared access so that you're not posting it in plain text. They're not perfect, but they're definitely a heck of a lot better than putting it in Slack. Some limitations. Nothing here is perfect, and I don't want to claim that it is, so just as a disclaimer here, there are issues with biometrics. Fingerprints can be cloned and used on a device using something like just glue, but that is rapidly improving in terms of the quality of these sensors. Same with Face ID. IR cameras can be tricked using various technological tricks. Again, this firmware is continuously being improved on the providers, so these issues should become much better over time. But I would say that regardless, these things are production ready. They can be used now for highly sensitive infrastructure. But if you have something that is extremely sensitive, well, do both, right? Both is good, because you can chain these things together to have a fully secure system where none of these issues exist. And to illustrate this, I have Extreme Auth, which I have Not patented, but maybe I will. You need a fingerprint to unlock your key on one device, Face ID to unlock a key on a second device, password and PIN to unlock a key on a third device, and then you get an email confirmation code or an SMS confirmation code you have to enter. And then you have to answer a security question, and then you get access to your system. Don't do this. This is dumb. Your developers will hate you, and they might quit, or they'll find some way to circumvent it. But it gives you an idea of how you can chain these together and how flexible they actually are and what your options are. And so with that, I will thank you for your time. This is my email address here. And feel free to send me any questions or comments if you want to discuss this or have any ideas for the talk. Yeah, just send me an email.
Thank you guys so much.
Thank you.
So let's see, do we have any questions for you?
Kyle, I loved your extreme authentication patent. You could also launch nuclear missiles easier, probably.
Sorry, were there questions?
Do we have any questions?
Questions?
Let's see if they're coming.
Coming up, probably.
No? Okay. Good.
We do have.
Oh, we do have a question.
Okay.
So, let me take the first. Which are the risks when using biometrics or other methods than passwords for authentications?
So I think that the top one and this one are kind of relevant, so I'll address them both at once. So biometrics are interesting when you're using a device because those have no reason to ever be sent to the company. Right? There's no reason for any provider to be collecting your Face ID or your fingerprint or any of those things. It should be stored exclusively on the device and used with a trusted platform module, which most new laptops are shipping with these days for this exact reason, which means that you can store it locally in a secure environment without it ever being sent to these different providers, which definitely helps address the user privacy concerns. And I know there was a provider, I can't remember if it was Instagram or something else lately, or Twitter, it was Twitter, that was talking about collecting user biometrics for some reason. That is not necessary in order to use biometric authentication. So I would say that people would consider that to be a risk, but it's probably not actually much of a risk. There are risks associated with being able to trick these sensors by capturing someone's fingerprint or their face with an IR camera and then presenting that to the computer, making it think that it's an external IR camera. But as I mentioned, those are being addressed fairly quickly.
So in general, we have biometrics all over the internet, such as platforms such as Facebook, Twitter, profile pictures. So it could be quite easy to collect those and...
Oh, absolutely. I mean, anywhere where you're uploading your picture, yes, that's going to be easy to collect. But my point is that that is not connected to biometric authentication, and it doesn't need to be. So that is an issue with privacy, absolutely, but that's not an issue because of biometric authentication.
Yes, I see. I see the point.
There's one more there. I can't quite see the whole thing.
We can't quite see it.
The issue with centralized passwords is the single point of failure or exposure. What is your opinion about that? And what is the plan B?
My opinion about that is you shouldn't use passwords. Get rid of them. That's the whole point. Yeah.
I think we have
Okay,
nothing.
so I think we have everything.
Okay, great.
So
Thank
this
you,
is
everyone.
for you. Thank you very much for coming to see us. So
It was a
long,
pleasure.
so long away.